In this video, we are going to learn how to factor polynomials of a higher degree, so beyond a quadratic or an x squared. So let's get started. First, we have x cubed minus x squared minus 2x. The first thing that you should always do when you are factoring is try to factor out something that each term has in common. So in this case, that would be an x. Each term has an x, so I'm going to factor out x. When I factor something out, that means I'm going to divide each term by what I'm factoring out, or dividing out. So in this case, x cubed divided by x is x squared. Negative x squared divided by x becomes minus x. Minus 2x divided by x becomes minus 2. Now, I have a quadratic that I can factor using the same basic methods as before. What multiplies to negative 2 that adds to negative 1? I know negative 2 and 1 multiply together to get negative 2, and when I add them, I get negative 1. So we have x times x minus 2 times x plus 1. And we're done. We have factored this polynomial into a set of 3 factors. Okay, so let's do another one. Remember, the first rule is take out what they have in common. These two terms, I have got negative 2x to the fourth plus 2x squared. I have a 2, and I can take 2 x's out, right, and x squared out from each of those terms. The other thing that you should try to do when factoring is take out a negative if your leading coefficient is negative. In this case, it is, so let's go ahead and divide that out. I'm going to factor out 2x squared. So when I divide negative 2x to the fourth by negative 2x squared, that becomes x squared. Now when I divide positive 2x squared by negative 2x squared, that becomes minus 1. So we have another quadratic, this time it's a binomial, that we can factor. This is the difference of squares. Which means that I can go ahead and factor it out into x plus 1 times x minus 1. I know technically I have x squared plus 0x minus 1. So what multiplies to negative 1 that adds to 0? Well, that would be positive 1 and negative 1. So that's the way difference of squares works. It's always the same number, 1 plus, 1 minus. Okay, next up we have a very long quadrinomial, and what we're going to do is we're going to factor this by grouping. So this only works for quadrinomials, or 4 terms in one polynomial. So you group the first 2 and you group the second 2, and we're going to treat these like they're kind of separate for a little bit, and we're going to factor out what the first group has in common. So the first group is 2x cubed minus 3x squared. There's not a lot in common there except an x squared. I can factor out x squared. And then I am left with 2x and a minus 3. From the second group, I can factor out a 9. So if I factor out 9, a positive 9, I am left with 2x minus 3. This is a good thing. The insides of our parentheses should be the same. The next step is pretty simple. What you're going to do is you're going to take the outside terms and put them into their own set of parentheses. The insides are just represented with one set of parentheses. The reason for this is if you were to multiply this back out, x squared, you would multiply it by both 2x minus 3, and then 9 also by 2x minus 3. So that's represented above. So we use that to our advantage to help us factor. All right. Now I have an x squared plus 9. Now this is the sum of squares. which is a little bit different than the difference of squares. Whenever you have a sum of squares, you're going to end up with imaginary factors or complex zeros. If this was x squared minus 9, we know this would turn into x plus 3 times x minus 3. Since we have x squared plus 9, this is actually going to change our zeros into imaginary. So I have x plus 3i and x minus 3i. So let's go ahead and factor that out. X plus 3i times x minus 3i times 2x minus 3. So anytime you have a sum of squares, x is being squared, 9 is 3 squared, they're being added, they will be imaginary. And that's as far as we can factor. Let's try a few more. Once again, I have a quadrinomial. So I'm going to go ahead and factor this by grouping. In my first group, I have 3x cubed minus 6x squared. I can factor out a 3 and an x squared. I'm left with x minus 2. Now, out of the second group, they don't really have anything in common, but for the purposes of factoring by grouping, we can say that they have a 1 in common, right? If I multiplied 1 by each of those, they wouldn't change. So I can factor out a positive 1. And we're still left with x minus 2. So once again, I'm going to take my outside terms and I'm going to put them into their own factor, 3x squared plus 1. My inside terms match, so I can represent them the one time with x minus 2. Now, 3x squared plus 1 does not look factorable, but it is. You can separate this. It's like the sum of squares. 3 is not a perfect square, but we can still square root it. So what it will factor into is the square root of 3x for the first term in our factors. I'm going to write that a little bit smaller. And we still have x minus 2. So I have root 3x. And just like before, I have a plus 1. 1 is a square number, but instead of plus 1 and minus 1, I have plus I and minus I, because this is the sum of squares. And now it's fully factored. Okay, this time we do not have a quadrinomial, we have a trinomial, and those exponents are a little bit higher than we are used to. First step, do they have anything in common? I can factor out an x as well as a 4. So I'm going to go ahead and do that. So let's draw a line here. 4x is what each of these terms has in common. I'm left with x cubed minus 10x, x to the 4th, not x cubed, minus 10x squared plus 9. Okay, so this, what's left inside, x to the 4th minus 10x squared plus 9, even though it is x to the 4th for our leading term, and then the middle term is x squared, we can treat this very similarly to a regular quadratic trinomial. So remember what we do with those is I say what multiplies to the last number that adds to the middle number. Well, in this case, that would be -9 and -1. So let's write this. I still have my 4x. If this was a quadratic, I would just split it into 2 sets of parentheses. Here we can do the same, but instead of x for our leading terms, we have x squared. And then I have -9 in one, -1 in the other. I have 2 difference of squares. I'm going to go ahead and factor them both. I still have the 4x out front. X squared minus 9 will become x plus 3 times x minus 3. And x squared minus 1 will become x plus 1 times x minus 1. And we have fully factored this very large polynomial into its 5 factors. All right, let's try one more. First rule, do they have anything in common? Yes, they do. They each have an x, and I can divide each term by 2 as well. So I'm going to go ahead and do that. 2x, left with x cubed plus 2x squared minus 18x minus 36. Okay, I can see that I have a quadrinomial. Okay, I have 4 terms, and the highest exponent is 3. So I'm going to factor this by grouping. All right, group 1. I can take out an x squared. Okay, I still have this 2x out front, so I'm going to write him first. And so I've got that x squared. I'm left with x plus 2. From my second group, I have a negative 18 for the first term, negative 18x, and then I'm subtracting 36. I can divide out negative 18. So I'm going to do that. I'm left with x plus 2, which is good because now my inside terms are the same. Okay, I still have the 2x out front from before. I'll take my outsides, x squared and minus 18, into its own set of parentheses, and then the x plus 2. Okay, x squared minus 18. 18 is not a perfect square, but we can still square root it. This will become 2x times x plus the square root of 18 times x minus the square root of 18 times x plus 2. And we have fully factored this polynomial.